Hello and welcome to this video. My name is Marco Nuyen and I'm a trainer at Microsoft. This video is part of a series of videos about the role of a Microsoft cybersecurity architect. The topic for this video is networking. Discover how network security shapes your organization's defense strategy as we dive into key concepts, real-world challenges and actionable tips every cybersecurity architect should know about. The content of this video is mostly aligned with the area of solutions for infrastructure from a certification perspective. Now, what can we do with networking elements? What can we do with networking elements in our security architectures and in deployed solutions? When I deliver a class, network is usually a topic that many people are very familiar with. You are likely to know something about networking too. And if you need to ramp up on networking, then there's plenty of content for that on Microsoft Learn that can help you. There's even a dedicated course on networking. Today, we will look at networking and specifically security considerations around networking. Now, networking is a key concept of Zero Trust, but it's not the only one. And we need to distribute our efforts and cover all areas, all 6 of them. And we need to ensure everything works together and is connected. And the element of Zero Trust that binds everything together, visibility, orchestration, and automation. Data from the network is essential to understand the patterns of threats on our apps, identities, data, etc. Things happen over a connection. Without networking, no connection. So, what is not mentioned on this slide is the principles of Zero Trust. Do you remember what those are? Verify explicitly, least privilege, and assume breach? To me, assume breach is the principle that I relate mostly to the networking. We will use segmentation and compartmentalization that will enable us to manage movement from one segment to another one. And it will enable us to isolate a compartment in case of an incident. Disconnect the network segments if needed to avoid further risk of impact. We limit the scope or damage. Impact is confided to only a part of the network. We can reduce the blast radius. Also, let me remind you that much of our efforts are about modernizing access controls and verify explicitly, for example, but also applies to the network. We can use Entra aspects like global secure access to be able to get into Zero Trust networking. There's excellent content on that in the learning path for the SC100 on Microsoft Learn. Go and check it out. But for now, let us focus more on some traditional networking aspects. Defense in depth. In our defenses, we need to do defense in depth, a security strategy that employs multiple layers of protection to prevent unauthorized access, damage, or compromise of assets and data. The idea is to create a layered defense that can slow down and deter attackers, even if they manage to breach one layer. Defense in depth also provides redundancy and resilience in case of a failure or incident in one layer. Defense in depth applies to all aspects of security, including physical, technical, administrative, and operational. One example of defense of depth in network security, which involves establishing network segment boundaries. Network segments is the practice of dividing a network into smaller subnetworks or segments that have different access levels and permissions. Network segmentation can help reduce the attack surface, limit lateral movement, isolate sensitive data, and enforce policies, and facilitate incident response. Network segmentation can be achieved using various methods, such as firewalls, routers, switches, virtual LANs, software-defined networking, microsegmentation, and Zero Trust network access. Network segmentation boundaries should be defined based on the principle of least privilege, which means granting the minimal level of access necessary for each segment. Network segmentation boundaries should also be verified explicitly, which means checking the identity and context of every request and transaction across segments. Network segments boundaries should also assume breach, which means expecting that attackers will try to penetrate the network, and we need to prepare for that accordingly. Now, to make sure that our designs and environments have everything they need, we can use a baseline again. Here again, I'm thinking about the Microsoft Cloud Security Benchmark, a benchmark that we see coming back again and again in the curriculum for Microsoft Cybersecurity Architect. Specifically, the control domain for networking, NS, network security. And as usual with the MCP control, we start with the lone number, which is a high priority, and we work our way through the rest of the numbered items. First is network segmentation. Should not be a surprise, right? Based on what I've mentioned so far. This is about protecting cloud-native services with network controls. Any idea how we do that? For me, the first thing that now comes to mind is private link or service endpoints to keep platform as a service private. Go investigate if you're not familiar with those. We'll come back to one of them in a moment. But use the NS controls in the MCSB. Go through them and think of an example on how you would achieve the control. And look up what is in the recommendations. And when you do, also notice that the guidance is not limited to Azure, right? Remember, the MCSB is a cloud security benchmark. It does more than Azure. And start thinking in patterns. Some of the networking aspects actually triggered me to talk about patterns here. And I've listed a couple of common patterns that I associate with networking. Patterns, best practices, framework like the well-architected framework, the Cloud Adoption Framework, the Microsoft Cybersecurity Reference Architecture, the Microsoft Cloud Security Benchmark, are effectively collections of patterns, things that lead to a favorable outcome. Then there are also anti-patterns in those frameworks. The pseudos and the likelihood of failure is very big, right? So if you do an anti-pattern, you're likely to fail. If you do a pattern, you're likely to succeed. So stay away from anti-patterns, follow a pattern. Be on the happy path. If you take a firewall that acts as a gatekeeper, that's a gatekeeper pattern. You put it in front of something to protect that something. And with many backends, we want something in front of them to secure them. Or have a concentrated place where we can aggregate all the traffic, inspect it, maybe even change it. Firewalls, load balancers, proxies, gateways, API management systems. Many of these align with patterns that I've listed here. Through the short link, you will be able to access pattern information in the Azure Architect site. Some patterns are also described directly in the Cloud Adoption Framework and the Well-Architected Framework. Why to look for patterns? Why to include them in your designs and assessments? Because they are typically robust. Technology or service will change, but what we want to achieve is the pattern is likely to remain the same. I want to have a gatekeeper where untrusted traffic meets trusted traffic. Great, let's implement a firewall from vendor, name a vendor. And later we can reconsider and we want to use another flavor of firewall. A firewall as a service maybe like the Azure Firewall. The pattern is the same, the technology is different. The pattern outlasts the technology. So use patterns and be familiar with them. Investigate these patterns. It will help you in your architect role. You will definitely benefit from knowing about them in the certification process. Now for some pictures, networking. Start small, grow big, concentrate traffic. That way we can create a single area for control and inspection and connect things together. We see some examples of Azure networking here, but in most environments the same pattern started to develop. We see a simple representation of that evolution model at the right side of the graphic. It is commonly known as the hub spoke. Like a wheel, we have a hub in the middle and we connect everything to that, spokes. The hub becomes the place for managing traffic, inspecting and so on. And then there are more hubs and there will be connectivity to on-premises and more and more. Long story short, we see the pattern that's evolved and that are described in the Common Practice Framework like the Cloud Adoption Framework. Here we have a link to the landing zone concept in the Cloud Adoption Framework. That has a lot of information on how to set up networking for different options and situations. It leverages the hub and spoke model and the successor of that with Azure Virtual WAN and software-defined networking capabilities. All those complex diagrams are made up of individual components and together they make up the pattern. Go to the link that I shared here, aka.ms/CAF-LZ, to find out more about these landing zone patterns. And more on the available landing zone types, diagrams, documentation. You'll also find code there. So many elements of the CAF are linked to repositories where there's actually code that can be deployed immediately or that you can use as a foundation to build on yourselves further. Azure segmentation elements. Segmentation, assume breach, reduce the blast radius, zero trust concepts. What are the components we can leverage to achieve that? Well, some of the components we can use for segmentation are the subscription, virtual network, network security groups, application security groups, firewalls, And what we see here is, of course, not a complete list, but they are essential for any networking solution running on Azure. So make sure you have them in your deployments and in your architectures. What's the best practice? Well, apply Zero Trust. But these are recommended practices for network on Azure based on that. We divide networks into segments, and we manage routing between those segments. For areas where we encounter untrusted networks, we'll use a perimeter zone with extra protection. For example, by adding a virtual network appliance. These are typically solutions from third parties that you can choose from a store and integrate easily into your designs. For example, when you prefer to use a different firewall than the Azure firewall, most vendors have their product available as a virtual appliance. And we practice isolation. If it's important, if it's critical, we will secure those resources. Case in point, suppose you've created a SQL database on Azure. That's Platform as a Service. And by default, Platform as a Service can be accessed from a public place like the internet. Likely that we need to take that out, no internet access directly. We need to make it behave more privately. We need to find a way to secure it and only make it accessible internally, where we need to access that. How would we do that? I assume you already have some understanding of how that could be done. And as part of a basic principle, that's going to be required from the cybersecurity architect role. This information is covered in courses like the Azure Security Engineer. And if not, then, well, maybe study about that. But there could be a capability, for example, like Private Link that can be used. There are two capabilities that come to mind to help make Platform as a Service capabilities more private. Capabilities that will expose or insert the Platform as a Service element into our Azure networks, our VNets and subnets. And those are Service Endpoints and Private Link. I mentioned them earlier, but I thought it was good to do a bit more detail on that in this video. And here you see an example of one of the two, of Private Link. Of the two, I would prefer Private Link over Service Endpoints. It is much more specific. Also, it will expose the service as an IP endpoint in one of the subnets, which gives me better granular control, for example, by using a network security group or filtering. But both have benefits and drawbacks in capabilities and in price. And it's essential to conduct thorough research independently or in consultation with subject matter experts in your organization to identify the most suitable solution for your circumstances. Additionally, consider the human factor. Implementation of a tool is only effective if users are equipped to utilize it properly. Security is more than just technology, right? It requires attention to people and process also. It's not only about choosing the technologies. People need to be able to operate it and understand it. Time to zoom out a little bit again. Let us connect what we just talked about from networking back to the Microsoft Cybersecurity Reference Architecture. And I hope the graphic that I have got here looks familiar to you because it's in multiple videos. It's a very wonderful slide to do some heat mapping with. That's the raw slide we see here. And I just want to highlight an area here. You've got the same slide here with that highlighted area where I think you will find the most elements related to networking. And where you're studying, also pay some attention to the Azure capabilities related to networking, like the web application firewall, the Azure firewall, next to elements that we already discussed in this video. That concludes our video on networking aspects. Now, there is still a lot more to learn, but I think we covered some of the essential aspects of networking in this video. The rest will depend on your own research and your existing knowledge. And for further reading, a good place to do research is the place that I've listed here with a short link. They are mentioned in design patterns. There's a cloud adoption framework, and within that also specifically the landing zone concept in the cloud adoption framework. Thank you for watching this video. There are more in the series of the Cybersecurity Architects to support you in your learning. I hope to meet you in another one, another time. Until that time, please stay safe.